Hello everyone, I'm Kanji Takahashi. I'm a first year master student in長岡 University of Technology. Today I would like to talk about construction of Japanese semantically compatible word resource. First of all, this is an abstract. We expect that the semantically compatible words are useful for alleviating the data sparseness problem. I will show an example of semantically compatible words. This word, kitty, black cat, domestic cat, refer to the almost central concept, cat. And we define this classification as hyponymy and hypernymy relation. And I will show another example case, beard, mustache, and whiskers. This word refer to the almost same concept. We define this word as synonymy relation. And we have constructed this semantically compatible word resource, and it contains 22,000 concepts. And it is integrated into our word analyzer. Let me talk about background. In the field of corpus-based and natural language processing, data sparseness is a serious problem. I will show example in statistical machine translation. Carlson Birch said use 10 million words for training, but half of trigrams in the test set does not exist in the training data. It is a serious problem. And the next, Nie and Weber try to solve the data sparseness problem with word notation generation, and it improves NLP tasks performance. So we have constructed Japanese word analyzer Snowman, which merge orthographical variants, because in Japanese sentence contains generally about 10% of orthographical variants. It causes a data sparseness problem. And so what is next step for solving the data sparseness problem? We think word representation generalization is next step. We propose that to reduce the amount of words representation by grouping words together. Grouping words and reducing words is to alleviate the data sparseness problem by grouping compatible words together. In the related works, as you know, there are many synonym dictionaries such as Soras and WordNet, and in Japanese, Goitaike, Japanese Lexicon, and the EDR, Electronic Dictionary. However, their classification is not semantically compatible words. For example, in Goitaike, dog and horse and cat, these words belongs to beast class. For example, we can see there is a dog, but we couldn't say there is a beast with replaced from dog to beast. This means these resources ignore the semantically compatibility. So we define the classification of semantically compatible words according to Kruswetsky discussion. We define semantically compatible words as words refer to the same thing. It is similar to paraphrase, and we define two types of categories. One is hyponymy and hypernymy relation. The other is synonymy relation. Let me explain about definition of hyponymy and the hypernymy relation. I will show example sentence. A cat meows under the tree. Then we can understand if the word cat was replaced by kitty. Kitty meows under the tree. We could understand, but we couldn't understand a beast meows under the tree. So we expect people generalize semantically meanings when we understanding the meaning of sentence. So we focused on the main message of the words. And secondly, we define synonymy as the part of semantically compatible words. For example, the word beard, mustache, and whiskers refer to the almost same concept, such as hair on the face. And also delay, return, and check refer to the almost same concept. And we know synonymy has slightly different meanings, such as word difficulty and informal or formal, new or old. But in this research, we don't consider about slightly different meanings. And next, we have combined constructed resource with word analyzer, because many existing resources are not combined with some analyzer. It means we couldn't make effective use. For example, difference of word unit and the difference of part of speech classification. So we have developed Japanese word analyzer Snowman. It generates orthographical variants, and it recognizes multiple word expressions. So our resource, semantically compatible resource, is integrated into Snowman. This is a construction outline of semantically compatible words. We use existing resources. If classification is similar to ours, then we extract by automatically, because it takes a big cost to construct from scratch. So we use existing resources. And if existing resources classification is not similar to ours, then we extract manually. And after extraction, if the word does not contain in Snowman's dictionary, then its words are deleted. And after matching, we register to semantically compatible words such as hyponymy and hypernymy relation and synonymy relation. And after collecting, there are some overlapped concepts. So in this research, we try to solve this problem by simple way. For example, this table are extracted words. For example, concept 1 and 2 are inclusive by concept 3. So inclusive groups are combined. It is very simple way. So as a result of collecting, we collected 343 concepts as a hypernymy and about 20,000 as a synonymy. And these words are example of collecting hyponymy and synonymy. And next, we try to qualitative comparison of snowman and goitaike. We extract similar relation from snowman and goitaike. In the hypernymy and hypernymy relation in goitaike, it are described as soras. Soras such as parent and children. And synonymy in goitaike, synonymy are described as sibling of soras. So we choose a similar concept for comparing. In the hyponymy and the hypernymy relation, for example, in goitaike, the word beast hypernym contains cat and the dog and the tigers as hyponyms. We think it is not semantically compatibility. So existing soras does not distinguish whether words are semantically compatibility. And synonymy in goitaike contains analysis and detection anatomy as the same group word, but detection and anatomy is different meaning with analysis. So, but in a snowman, we collect analysis with only analysis with same concept, which means snowman explicitly defines semantic compatibility. To conclude, we have proposed to reduce the number of word representation with semantically compatible words, and we have integrated constructed resource into Snowman Word Analyzer. Thank you for listening.